Okay, so now we're going to get into media failure recovery. In RAC environment, media recovery is about same as just a single instance environment. So in the next few slides, we're going to see a couple of considerations or small differences that we have to be aware of. Protecting against the media failure. Even though RAC database provide a multiple access point to Oracle database as a high availability solution, if you have a storage problem where your database physical structure problem, that will cause your instance failure, and also that will cause your database in a crash. Okay, so your environment should have a way to recover your database as quickly as possible based on your business requirement, and also to minimize loss of data. Okay, as a best practice, your database database should be in the storage that support mirroring, and also before mirroring, it's a good idea to multiplex important files. For example, control file is an important file. So in order to avoid recovery scenario, you may want to create multiplex the control files. So loss of one control file doesn't cause a recovery scenario because we can simply copy control file if you have a multiplex the control files. And also same thing, online redo log member. You should have multiple members across different the disk devices and different mount point or different ASM disk groups. So that way we can avoid a single point failure. And then configure your database in archive log mode. That's another best practice. Okay, so that way if you have a problem with a database and you can restore your backup and you apply redos in archive log file to recover your database. Okay, and also create backup. In the just worst case, if you have entire data file loss because of an entire data center problem, then you will have to think about another solution like a data guard. Okay. Media recovery in Oracle RAC. Media recovery must be user initiated through client application, meaning that you will have to make decision whether you want to fail over your database to new site or you want to recover your database. If that is the case, at which scope? Do you want to recover your database at block level? Do you want to recover your database at the file level? Do you want to recover your database at the logical level? So you will have to make decision that's user initiated. And the best tool that we can use to recover your database, even in RAC environment, RMAN is recommended. When using RMAN in RAC environment, the backup and recovery, the processes are about same. And the nodes that perform the recovery must be able to restore all of the required data files, and that node must also be able to either read or redo required archived redo logs on disk or restore them from backups. Okay, think about archive log file. Archive log file is an optional file, which means that you don't have to create archive log file in the shared storage. Since it is optional, you may want to create archive log file in the local storage, for example. Okay, so you have a local archive destination in host shader 1 and local archive destination in host shader 2. And suppose that you have a database recovery scenario. So instance 1 running out of host shader 1 is performing recovery. So since our backups in the disk location in ASM and backups are accessible, no problem. But suppose that archive log file is not accessible in the second server because we configured the local archive destination, but we haven't configured local destination available to remote site. So if that is the case, instance that is performing recovery cannot read the entire archive log files. Then recovery is not possible. So that's our consideration. And when recovering database with encrypted table spaces, the wallet must be open. If you are using encryption, then a wallet must be open to be able to read master encryption key. By doing so, we can encrypt and decrypt table spaces. And we had a discussion of this in lesson 4. And also we have a terminology. Instance recovery and crash recovery. So what's different? It's the same. But main difference is instance recovery means if you recover subset of instances in your database, that's instance recovery. For example, I have a 3-node RAC database. I lost a subset of instances. So I lost one of the instances. Then that's instance recovery. Now I lost the entire instances of a database. Then there is a crash recovery scenario. I have a standalone database and single instance database. I lost one instance that was the only instance. Then there is a crash recovery scenario. During the instance of recovery and crash recovery, Oracle uses the optimal number of parallelism based on the CPU availability of a CPU. Okay, and for the media recovery, when you restore and when you issue restore command and recover command, and we can actually take advantage of a parallelism because we are able to configure channel, and channel is a special process that is responsible to read the input file and also create backup, or that is responsible to restore backup file and then restore back to original location. So when you recover, your backup, your recovery process can be parallelized as well. So here are the 3 examples. When you restore data file, we can parallelize, and when you apply incremental backup and archive log file backup, we can use the parallel recovery processing. And to disable parallel instance and crash recovery, set recovery parallelism parameter to 0. This will disable parallel instance and crash recovery. Okay, so faster recovery area. Faster recovery area is a backup location. Okay, it is a default backup location. If you want to create backup to the predefined location, then configure faster recovery area and create backup to that location. Most likely, it's a good idea to keep the latest backup in the disk location for faster restore. Okay, and you can configure faster recovery area with a cluster file system, or you can use ASM as a faster recovery area, or you can use certified NFS directory. That's your choice. Let me take a look in our environment. So I don't need this. So I'm going to close it. And I'm going to log in. SQL plus as sys DBA. And show parameter DB recovery. Okay, so in this example, we have a DB recovery file dest. That's a parameter to configure faster recovery area. In our case, we chose ASM. And also, we have a size of it. So it's 8100 megabytes. So this is the way to configure a faster recovery area. But you can use NFS mount point, and also you can use a cluster file system as well. And when using Enterprise Manager, you can go to availability, the menu, and backup and recovery, and backup settings. In the backup settings page, and you have an option to configure your database in archive logo mode. Okay, and also log archive file name format must include %T, %R, %S. That's required. So your file name must include the 3 items, and your backup and archive logo file goes to faster recovery area. If you want to change the location, yes, you can change it. And also, you will see contents of a faster recovery area. And if you want to configure your database in archive logo mode, you choose this option. And you can also do the same thing in the command line interface. For example, let's see here. Archive log list. So in my current log archive, archive log mode is no archive mode. So what I'm going to do, so I want to actually configure my database in archive log mode. So how can I do? And my database is a RAC embodiment. So what I can do is, so I can do this way. And I'm going to actually stop database. So I will have to stop database. So I'm stopping my database cleanly. When you shut down a board, then archive logo configuration will fail, because in order to configure your database in archive logo mode, your database must be must be synchronized. So before shutting down database, checkpoint must be issued. By doing so, at mount to state, you can deconfigure your database in archive logo mode. So my database is down. So let me double check srvctl status database -db orcl bubbles. So let me check my database status. So everything is down. That's first step. Second step is you will have to start one of the instances. srvctl start instance. So this time I'm starting instance. And then I will use instance name, database name. So in this case, orcl and instance name. In this case, I will use orcl _3. Now when you hit enter, this will cause the problem. Why? Because, so let's take a look at this. I'm going to connect to host 01. And then let's check here. srvctl config database -db orcl, hit enter. So when you look at this, you have a start option here. And this is open, meaning that when I hit enter here, then my instance will be started up to open state. But you cannot configure your database at open state. So you have to start your database up to mount to state. Okay? So I'm mounting one of the instances up to mount to state. And now I will configure my database in archive logo mode. Okay, so I'm going to log in now. And make sure you're in the ORCL3 instance. So I configure the database in archive logo mode. So as you can see, so my database in archive log mode. And now I'm going to shut down this database. And now I will start up entire instances. So I will start in a few seconds. Okay, now srvctl start database -db orcl. So I can start now up to open state now. So I don't have any problem. This way, you can configure your database in archive log mode in the command line. So this is in addition to Enterprise Manager option. So here we have archive log mode. It also requires restarting your database. And archive the redo file name must include the %t thread number. Now we know what is the concept of a thread. Each thread number assigned to each instance. %s is a logo sequence number. %r is a reset identifier. So your archive log file name must include the %t, %s, %r. And then we're going to configure RMAN backup settings with Enterprise Manager. So here we have in our channel, so you can allocate one or more channels, and your backup goes to backup destination. By default, your backup location is a faster recovery area. And you can create backup as a backup set, or you can create backup as a compressed backup set, and you can create backup as an image copy. So you choose your output file format. So you read the input file, and you're going to create output file, which is your backup. What should be your output file format? So you can create backup set backup, or compressed backup set backup, image copy backup. You can also configure tape backup as well. And in order to create backup to tape, you will have to install Media Manager software. And then you will have to use a special library to create backup to tape. And if you go with the Oracle tape backup solution, you can use the Oracle Secure Backup solution. So you can integrate RMAN with the Oracle Secure Backup to create backup to tape. RMAN provides the following benefits for real application clusters. RMAN can read cluster files or ASM files with no configuration changes. And it can also access a multiple archive destination. So in RAC embodiment, just like a single instance embodiment, it's a good idea to use RMAN. In this example, RMAN, it create backup. So basically, it read input file, which is database file, and also write it to backup destination. And this is an Oracle server process. And this special Oracle server process is called channel process. So we use our channel process to read it and to create backup file. In the next few slides, we're going to see RAC-specific configuration. And the first example here is snapshot control file. So what is a snapshot control file? So think about it this way. We have control file of database. Now, this control file is very, very busy because it is accessed by multiple instances. For example, if you have a 3-node RAC database, each instance will access to control file to update metadata information, especially system change number, every 3 seconds, okay, at least. So that is called, that's part of our internal checkpoint to keep the latest the timestamp information. So every few seconds, instance 1 access to control file to update metadata. Instance 2 also do it. Instance 3 also do it. So instance will keep new information over and over. So it becomes in a hot file. In two cases, you need a copy of a control file to provide the consistency. The first example is if you want to create the backup of a control file, then rather than creating backup control file from the production control file, we create copy of a control file first and create backup out of the copy of a control file. And this copy of a control file is called snapshot control file. It provides the consistency at the time when you request it, based on the time that you request it. So I'm creating the backup control file. At that moment, your control file is copied as a snapshot control file, and then from snapshot control file, we create a backup control file. And this snapshot control file must be in the location that is accessible from the instance that is performing in operation. So it's got to be shared location, so that way every node can access to that location. Or another case where we use a snapshot control file is if you want the synchronized catalog database. So if you want to create, if you want to synchronize the catalog database by pulling out information from control file, so at that point we create copy of a control file first, and then from the copy we synchronize catalog database as well. So in that case, we also use a snapshot control file, and location must be visible to all servers in the cluster. So in this particular example, we use a show snapshot control file name, and rather than using local file system, I want to use the ASM or cluster file system as a location of snapshot control file. So in RAC environment, you configure snapshot control file location that is visible to all members of a cluster for RAC instance access. Okay, so now configuring control file and SP file auto backup. So what is auto backup? Auto backup is the backup of a SP file and control file. Okay, when do you create auto backup? When you enable auto backup by issuing configure control file auto backup on, then at the end of each database backup, your control file will be backed up and your SP file will be backed up. So we want to create auto backup to keep the latest the backup image and also latest system change number, because when you recover database, we recover database based on the latest number that is saved in the control file. And in the auto backup, we also want to include the SP file, so that way I can start my database normal to state in case of the loss of SP file or P file. So where do you want to create this SP file and control file? And we want to create SP file and control file in the shared location that can be accessed by all nodes in RAC database. In this example, we chose ASM disk group. And also cross-checking on multiple RAC cluster nodes. When you cross-check on multiple nodes, make sure that all backups can be accessed by every node in the cluster. Makes sense? What is a cross-check? The cross-check is checking missing the backup files by using the RMAN catalog in the control file or catalog database. So let's say we created a backup of data file 1, 2, 3. So metadata are already available in the control file. Okay, but to save space, you manually moved backup of 3 files to a different location. Okay, so when you run crosscheck command will read RMN metadata in the control file, and then check the existence of files, backup files. If a backup doesn't exist in the right location, your metadata will get updated to expired, meaning that you have missing backup files. So if this is this was on purpose, then you can actually delete expired backups, and also you can recatalog. Okay, or if if that is not the case, then you have to take another action. So make sure when you do cross-check, the backup files must be available to all members of a cluster, or at least must be available to the instance that is performing cross-check command. Okay, so we're gonna see channel allocation. As I said, we use channel process, special server process, to read the input file and to create backup, and also to restore backup. So how can I configure channel processes? So we have 3 different options. So let's take a look at these examples. So I made a first example here. And in this example, we do have this setting, configure default device type to SBT, meaning that this is used when creating backup to tape. And I want to enable parallel tape backup. So in this case, SBT parallelism 3. Now, where do you want to start 3 channel processes? In this particular example, we have this configuration. Okay, so we have this configuration, ORCL1, ORCL2, ORCL3. Assuming that ORCL1 is a net service name that is pointing to ORCL1 instance, ORCL2 is a net service name that is pointing to ORCL2 instance, ORCL3 instance, and so on. So, you're gonna connect to database using this method. So RMN target sys password at ORCL2. So we connect to a second instance in this way. And when you issue RMN backup, okay, which process is responsible to create backup? Sometimes the customer misunderstand. This backup command is by this server process, this session. But the backup is not by this session. The backup is actually by channel processes. Since we configure the channel to run it out of each instance, when you initiate backup, one channel will be started in instance 1, another channel will be started from instance 2, another channel will be started from instance 3. So by leveraging all 3 instances, we will create backup. That's one option. Okay. The second option is this. So when you look at this example, it's also same thing. You want to create backup to tape. I want to create parallel backup, but this time I used another alias here. Okay, so what is this? And this alias is the service. So suppose that this is a net service name, and that was defined in the tnsnames.ora, and your net service name is referring to service. And we created the service in this way. So in this case, srvctl database add service and dash database ORCL, and I'm adding service named pkp_serve. And this service is referred by this net service name in the TNS name entry. Okay, so I made a preferred instance. In this example, my preferred instance is ORCL1, ORCL3, and that is a location where service exists. And also ORCL2 is available instance. Okay, so in this particular example, my service is running out of instance 1 and instance 3. So I must allocate channel processes in the locations where service exists. So I have to start channel here and channel here. Now we have 2 locations, so we have to spread channel processes. We use load balancing feature. If ORCL3 is considered as a least loaded instance, then we start more channel processes in instance 3 to create backup. So that is a second option. So you can use this option to control your RMM backup channel locations, and also to use another instance for different purposes at night, for example. So that's another example. And what about this? We have a third option. This time, I didn't specify net service name, meaning that this time we will consider all 3 instances as location for channel process. So we don't have a control. So in this case, based on load balancing, we may actually start channel processes only one location if ORCL2 is considered as the least loaded instance, or maybe spread across all 3 instances. So we don't have a control. So you have the 3 possible options. So based on your requirement, you can choose one of the 3 possible options. So that's what I explained. And RMN default auto location. So recovery manager, it records backup information and also original location of input file. So when you restore backup, RMN knows where to restore backup pieces, and also archive read logs, and also data files and control file copies. And if local archiving is used, a node can read only those archived logs that were generated on that node. So the question is, what is local archiving? Okay, I'm going to give you a conceptual idea here. So here's an example. Archive log file is an optional file. So when possible, it's a good idea to create archive log file in the shared storage for the simpler management. When you create database, okay, and you configure a database archive log mode, most likely we keep archive log file in the shared storage, in this case FRA, in our case too. But if a customer wants to use, or if you want to use, the network attached storage, for example, then you can also use the local archive log file destination. For example, I have one storage that is a local to host share 1, another storage that is a local to host share 2. Okay, and this storage mounted to host share 1 with a read-write mount option, and then we mounted under user1 arc1 directory mount point. And also in the second host, we also have another storage that is mounted in the second host, and in a mount point is user1 arc. Okay, so that is the example. So in this case, you create backup of this archive log file to the backup destination, and backup of this archive log file to this backup destination. Okay, in order to restore backup of this archive log file that is in the local storage, this instance running on host share 1 must perform restore operation. Okay, so that's the local archiving scheme. And also another problem here is this storage is not visible to host share 2, and this storage is not visible to host share 1. So this will cause another problem. So the better way to configure this is you will have to make it available to host share 2, and you mount it in host share 2 with a read-only mount point. And you also make this available to the host 01, and you have to mount it with the read-only mode. So by doing so, both nodes can see the archive log files in the local destination. So that is an example of archive the log file in the local file system. And the better option is, you can keep everything in the shared storage. So I want to keep archive log file directly in the shared storage. So then you don't need additional configuration. And distribution of backups, and we saw that we can choose only one instance to create backup, or we can choose a subset of RAC database to create backup, or you can choose entire instances to create backup, or you can choose a backup, the backup server to let it create backup. So we can create backup different way in RAC environment. So that's what we saw as part of the first three options. And managing archive the read logs using RMAN. So as we saw in the diagram before, we can create archive log file either in the local storage or in the shared storage. If you choose local destination, then it's a good idea to make the same storage available to the peer members with a read-only open option. So this is our example. So with a local archiving and set local archive destination with the NFS mount point. And then we will have we can also create node and instance bind to ensure instance always run on specific node for the policy managed database as well. And when you create archive log file in the cluster file system and the shared file system, then it's much easier. So you only use either the CFS mount point, or you can use ASM as location of archive log file. And your archive log file name include the %T, which is thread, %S, sequence number, %R, reset number. And restoring and recovering. Media recovery may require one or more archive log files from each thread. Makes sense? And RMAN recovery command automatically restores and applies the required archive logs because it knows the exact location and what should be restored. And archive logs may be restored to any node performing restore and recover operation. Log must be readable from node performing restore and recover activity. So up to this point, it's very easy to understand. But the last two items, recovery process request additional thread enabled during the recovery period. What does that mean? And recovery processes notify you of a thread no longer needed because they were disabled. What does that mean? Think about that. You're about to recover your database, and so you have to restore backup. Now, the time when you created the backup, your RAC configuration was a 2-node cluster. Okay, but the current configuration is 3-node cluster. So when you restore backup, okay, we will have to match thread. So your backup only include 2 threads, but my configuration consists of 3 instances with a 3 thread. So the addition of a thread, that's automatic as a part of a recovery process. It's also same vice versa. You had 3 instances when you created a backup, but the current configuration is 2 node. So initially you restore backup, and you have to disable 1 additional thread to match it with the current RAC configuration. And this is automatically done behind the scene. So we don't really have to worry about this area. And we have a quiz here. Which of the following statement regarding media recovery in RAC is not true? So the question is not true. Media recovery must be user-initiated. That is true. And RMAN media recovery procedures for RAC are quite different from those for single instance embodiment. No, it's about same. So B is the answer. The nodes that perform the recovery must be able to restore all the required data files. Makes sense. The recovering node must be able to either read all required archive logs on disk or restore them from the backup. Makes sense. So, the answer is B. And to use a faster recovery area in RAC, you must place it on the ASM disk group, cluster file system, or share the directory that is configured through certified NFS for each RAC instance. The answer is true. So I covered a second part of this lesson, and that was about media recovery scenario. So in the first part, I covered the instance recovery with a short demo, and second part was a media recovery with a short demo, especially focusing on RAC-specific considerations. Okay, this is lesson 6.